Tangent fields. A tangent field, or slope field, or direction field, is a visual representation of a first-order differential equation. It consists of small line segments, or arrows, drawn at points in the plane, where each segment's slope represents the value of the derivative at that point. Tangent fields provide insight into the behavior of solutions of differential equations without solving them explicitly, showing trends like growth, decay, or equilibrium. And this is a good thing because we can't always solve differential equations. It's not always like your exam where you're going to get given an equation that you know how to solve. The whole world can basically be expressed in differential equations, but most of them aren't soluble. But you can use tangent fields to get a picture of what the solution might look like. So what do I mean by that? Well, let's suppose we have dy dx is equal to xy. Then dy dx evaluated at the point 1, 1 would be 1 times 1 is 1. Dy dx evaluated at the point 2, negative, let's make it 2, negative 1, would be 2 times negative 1, which is negative 2. And that means on a graph, at the point 1, 1, you can draw a gradient of 1. At the point 2, negative 1, you can draw a little line with a gradient of negative 2. And you build up a picture of what it looks like. So we could look at this because you can actually do it on the class pad. And if I just go to menu, the one that you want here is differential equation graph. And then you can type the equation in up here. For example, we could put x divided by y. And execute. And if I get rid of the keyboard, it should draw me a tangent field. I just need to make sure that's input. I think we might need to put initial conditions in. Let's put in 1, 1. And I don't think we actually have to do that. Let's just now click on that. And it produces a tangent field. And we could actually make this bigger and have a look at it. In fact, I think I'll do that in a minute. It's drawn the solution that goes through 1, 1 for me here. If I take out the initial condition and regraph it, it's just going to give me the tangent field. Let's have a look at that bigger. So notice that I typed in the differential equation x divided by y. And it produced for me this tangent field. Now, if you think about everywhere where y is 0, so on the x-axis, we would have x divided by 0, which is undefined, or an infinite gradient. And you can see these very steep gradients along the axis, like so. If you think about anything that's on the line y equals x, x and y would be equal, and the gradient will be equal to 1. Now, let's just see, because the aspect is strange here, because we're going from, well, we've got negative 5 to 5 here, and negative 2 to 2 here. Now let's just try and make that window square. And I'm not sure that we can do that. But let's just go negative 2 to 2 on that axis as well. And then at least we might be able to identify the point 1, 1, which looks like it would be about here. And that gradient of the point there at 1, 1, which is where you can see my mouse pointer now, should be about 1. It doesn't look like it's a 45-degree line, and again, that's because the window is wider than it is tall, so the aspect isn't perfect. But you get the idea, and I think this is a better picture than the original one. You can see what's happening if you have a situation where x and y are both positive, as they are in the first quadrant, then you're going to get all positive gradients in there. If you have a situation where one of them is positive and one of them is negative, you're going to get negative gradients like we do in quadrants 1 and 3, where they're both negative, positive gradients as we do in number 4. And then what I did initially, I put some initial conditions in here. And let's start this one as we can't really do 0, 0 because 0 divided by 0 is undefined. We'd have a problem at the origin here. But let's go for, well, if we stick with 1, 1, we're going to get a straight line, aren't we? So let's put that initial condition back in and graph it. We're going to get a straight line because it's going all the way along where y is equal to x. There might be a slight hole in this graph at the origin where that's undefined. And if we went for something different, let's make that 0.5, say. Then graph that, and then we get that curve. And you can see how the curve is following the tangent lines. This is a skill you need to practice because you will get tested on that type of thing.